In this video, we will be discussing the birthday paradox. We will be answering a couple questions. First, you walk inside a room and there's a total of 23 people. What is the probability that at least 2 will share the same birthday? And can we come up with an approximation and general formula for n people? What changes if we include leap years? What happens if there are more than 365 people? And what is the probability someone has the same birthday as you? When are birthdays most common? Our approach. We will use the complement rule to look at the probability that no one has the same birthday. So in other words, we're going to take 1 minus the probability that no one has the same birthday. For each individual, we will look at the number of days that have no birthdays over the total number of days in a year. This means we will look at all the unique days where no birthdays happen, and that's going to be over the total number of days in a year, which if it's not a leap year, it's 365. When a day is taken by someone's birthday, the number of days with no birthday decreases by 1, but the total number of days remains the same. So for example, if somebody goes and there were 360 days available, he chooses one of those days. Now, for the next person, there are 359 days available. Okay, what happens when there's 23 people walking in a room? Well, how many ways can the first person choose his birthday? Well, there's 365 days in a year, so he can pick any day he wants. So it's going to be 365 over 365. The next person chooses birthday. Since one day is chosen, he has 364 days remaining. So there's going to be 364 days out of the total 365. We continue this pattern, and for the 23rd person, well, that means that 22 people have gone. And those 22 people have chosen a unique day. So we will take 365, subtract it by 22, and that will be 343 days for him to choose. So 343 out of the 365. Now how do we calculate this? So we're going to multiply 365 over 365 with 364 divided by 365 all the way up to 343 divided by 365. So there's going to be a total of 23 fractions. And when we multiply this, we get a 0.4927. So that is a probability that no birthdays will be shared out of the group of 23. And we subtract it by 1, and we get 0.5073. So there's slightly greater than 50% chance that at least 2 people will share the same birthday. Let's look at the formula. We can represent this formula by 1 minus 365 factorial divided by 365 to the n times 365 minus n factorial. Notice that 365 factorial divided by 365 minus n factorial is a permutation formula, where n is 365 and k is n. So we can replace that and rewrite it as 1 minus permutation with inputs 365 and n all over 365 to the nth power. Now if we use this formula and write it out or graph it for the 100 days, well, we see that at day 41 there's about 0.903152 probability that at least 2 people will share the same birthday. And with 57 days, the probability increases to 0.99012. So there'll be about a 99% chance with 57 people. And at 70 people, there'll be a 99.916% chance. So one thing to notice about this increases very quickly. We can approximate our formula as follows. We can take 1 minus the quantity 364 divided by 365 raised to the n choose 2 power. So notice the exponent is a combination. And we can also represent it by square root of n. Now, square root of n isn't the greatest approximation, but it's still decent. Let's consider leap year. Well, what's different about a leap year? We have an additional day. So instead of looking at 365 days, we will be looking at 366 days. So for the first person, he will have access to 366 days out of 366 days. The next person goes, and 1 day is taken, so he's left with 365 days. And so on. Until you go to the 23rd person, and he will have access to 344 out of the 366 days. So really, all that changes is we add 1 to the numerator and the denominator. Okay, what happens if there's more than 365 people? If you assign 1 person for each day of the year, there will be 365 people with unique birthdays. For every additional person, so every person that exceeds 365 people, they will have to share a birthday with someone else. This means that there's a 100% chance that at least 2 people will share the same birthday. Next, let's look at the probability that 2 people will have the same birthday. Well, we're going to look at this as 1 minus the probability that they do not have the same birthday. And here I'm considering not leap years. So if the first person chooses his birthday, there's 365 ways he can choose his birthday. And the second person goes, so he's left with 364 days out of the 365. So when we multiply those two fractions and subtract by 1, we get 0.0027. So less than 1% chance then that you or I will have the same birthday. And finally, which birth dates are most common? Based off this map, we see that the lighter color represents birthdays that are less common, and darker color means birthdays are more common. Clearly from this graph, we see that the months of July through September are the months with the most common birthdays, and months like January and February are the least common.